Hey everyone, today we are going to solve a classical and powerful algorithm which is known as binary search algorithm. It's a super efficient way to find the elements in the sorted list by cutting the search range in the half each time. We will walk through the logic, write the Python program, write the Python code and understand the each step visually and practically. So let's start the binary search algorithm. So before starting the binary search algorithm, we must make sure that the list which we are taking uh, should be having an order, whether it's an ascending order or descending order. So I need to find I need to find the index position of my target variable, which is 8. So I need to, with the help of binary search algorithm, I need to find the index position of the 8. So the idea behind the binary search algorithm is we need to we need to uh, reduce the size of the list by half each time in the iteration. We will be doing it by finding the middle element of the list, and we will be comparing with the target variable. So in my case, in the first iteration, we can see that the starting index will be the 0, and the ending index will be the length of my list minus 1. And we will be calculating the middle index position by start plus end floor division operator, and floor divisioning it by 2. Then we will be getting 4. So if we see the fourth element in my list, which is 5, and the target is 8. So the target is 8. So the target is greater than the mid so the target is greater than the my middle element. So here we can exclude this 1 2 3 4 prior to the fifth. So we can exclude this and shift my starting position to this middle element plus 1, middle element plus 1. So only remaining part of this my list will be 6 7 8 9. And in the next iteration, and in the same way, if my target was now it is 8. In the same way, if my target was smaller than the mid element, like 2 3 or something, so what I will be doing is, starting position I won't change, but the ending position will be mid minus 1, because this part is no use to me. This part is no use to me. The only necessary part for me is this part. So I will be using this. So coming on to our context now, 8, the starting position has been changed because the 8 is greater than the mid element, which is mid plus 1 is 5, and ending will be the same 8. And again we will be finding the middle index position, which is 6, and the middle element will be 7, because uh, 0 1 2 3 4 5 6. So sixth will be 7. And if you again compare the target variable with the middle element, the target variable is greater than the mid. So what we need to do, again we need to shift the our start variable by mid plus 1, which will be a 7, and the ending will be 8. And we'll be finding the mid index position, which is 7. So the seventh element in my list is 8. And if we compare our target variable and the mid element is same. So here we can stop the loop and print the index position of the list. So this is the whole internal mechanism behind the binary search algorithm. So as we have now seen the working, let's write the code for it. So I will be uh, making a function for binary search. So the parameters will be, I will be taking the two parameters. One is my list, and then the target variable which I need to find. I will be initializing the start as 0, start index as 0, and the end index equal to length of my list minus 1. So we will be starting a while loop while start is smaller than or equal to end. Till the starting position is smaller than or equal to end, the program will run continuously, and inside the while loop I will be updating the mid, which is start plus end, floor division operator divided by 2. So I will be getting the mid position, and I will be checking at the first itself whether if my list of mid position is equal to the target. If it is equal to the target, then we need to return the mid position. But if it doesn't, then I need to write a elif statement that if my my list of a mid is smaller than the target, then obviously I need to shift my starting position by mid plus 1. And if it's not in the this also is not the case, then we need to bring the ending position by mid minus 1. So if all these conditions do not satisfy, we can return a minus 1, which indicates that the element which we are trying to find is not in the my list. So we have created a function. Now let's uh, define the arguments. So 1 2 8, okay, and the target which we are going to find is 8. So result will be, we will be calling that function binary search. Will be passing the arguments my list, a target. So I'll be printing the index and the result itself. So if I try to execute this, so we got the index position at 7. So if we see uh, the in the 8, the target element is on the index position of the 7. So which is correct. So this is all about the binary search algorithm working principle. It's a simple, fast, and elegant, perfect. But one thing for the binary search is the list should be in the ascending or descending orders, and it is a must known for coding interviews. Uh, Thanks for watching and happy coding.